All right, so you just finished your formative or your practice quiz, and we're going to go over the answers and just see how you did. All right, so in section 1, you were asked to identify the main structures of the periodic table. So the question here was asking what general area of the periodic table are the metals located in, and we're looking for you to tell us the left side of the periodic table. Okay. Don't just draw an arrow, just actually write the word left. The next question says, what general area of the periodic table are nonmetals located in? And you would probably write the right side. And that's really all that we're looking for there. When asked to name a metalloid, you could have written anything from boron, silicon, germanium, arsenic, antimony, or tellurium. You could have written their symbols as well, but those would be the 6 elements that I would probably choose from. Which group contains the alkaline earth metals? And I'm looking for you to tell me group 2 or column 2. That's what we're looking for there. Any questions on the first section? All right, the next section asks you to identify valence electrons in charge, and hopefully you might have recalled that at some point this week, and I think it was yesterday, we actually went through and wrote down some charges and stuff on the periodic table, and then also wrote down some valence electrons. So hopefully this part was super simple for you, right? Hopefully for fluorine, you said that there were 7 valence electrons, and the charge of fluorine would be a -1. Hopefully for nitrogen, you said that there were 5 valence electrons, and the charge for nitrogen, hopefully you said was a -3. And hopefully for beryllium, you said that there were 2 valence electrons. And for the charge of beryllium, you wrote +2. Okay. To review, 7 valence electrons, the atom is going to gain an electron. That's why it becomes a charge of -1. 5 valence electrons, the atom is going to gain 3 electrons. So that's why it becomes a charge of -3. And beryllium has 2 valence electrons. The atom is going to lose 2 electrons. So it becomes a +2. Any questions on that section? The next section, you were asked to identify whether or not a compound was ionic or covalent based on what you were given. So in this instance here, the first one, FeCl3, I said was ionic. I knew it was ionic because Fe is a metal and Cl is a nonmetal. That doesn't make sense. Non-metal. Okay. The next one, cobalt, or CO rather, not cobalt, is covalent. And I knew that because carbon is a nonmetal. So is oxygen. You could have also written something like no metal present. Something like that. Next one is also covalent, NH3. Because nitrogen is a nonmetal. And hydrogen is a nonmetal. And you could have also written no metal present. Any questions about those? All right. The next one is drawing Lewis dot structures. And as a review, when we draw Lewis dot structures, I'm going to put an E for the element symbol. What I've been doing or telling you to do is to draw 1, a 2, a 3, a 4, a 5, a 6, a 7, and an 8, like in that pattern. So we'll do that as we go along and do the next three. So calcium is a metal. I'm going to write its symbol, which is Ca, and then I'm going to put dot here and a dot there. Sulfur is a nonmetal, has 6 valence electrons. We're telling you that, and so I'm going to put 1, 2, 3, 4, 5, 6. Okay, and then lastly, arsenic. It's technically a metalloid, but it behaves more like a nonmetal than a metalloid. So we're going to draw 5 valence electrons as 1, 2, 3, 4, 5, something like that. Any questions about these? Okay. Yes. We're going to show the process of what happens when a metal and a nonmetal get together in an ionic bond. What they do is they transfer electrons. So here I have strontium with 2 valence electrons and a nitrogen with 3 valence electrons. And the very, very first thing I'm going to do is show transfer of electrons. So I'm going to show a transfer by drawing an arrow to this nitrogen here from that electron from strontium and transfer like this here. So my strontium here has lost its 2 electrons, and nitrogen has gained an electron, gained 2 electrons. Strontium is in good shape because strontium wants to lose its electrons, and so when it loses those 2 electrons, it gets a charge of +2. Okay. Nitrogen, though, needs to have 8 electrons around it, and right now it has 7, so it's not completely satisfied. So the only thing that we can do at this point is add another strontium, like so. And I'm going to show that one of the electrons from strontium transferred to that nitrogen. So now my nitrogen, right, has its 5 original electrons, 1, 2, 3, 4, 5, and then it now has electrons from the first strontium and the second strontium. So this time nitrogen had 5 electrons to start with. It gained 3, and in the process of gaining 3, it now has a charge of -3. However, my second strontium is not satisfied, and as a result of my second strontium not being satisfied, I'm going to go ahead and add another nitrogen. And when I add that second nitrogen, it's going to have 1, 2, 3, 4, 5 electrons on it, and I'm going to show transfer of electrons over here. So now my second strontium has lost 2 electrons, so its charge is going to be a +2. But my second nitrogen has only gained 1 electron, and it needs 2 more to get to 8. So I'm going to draw a third strontium over here with 2 more electrons on it. And then I'm going to transfer those electrons to the nitrogen, to the second nitrogen, just like that. And so now my third strontium has lost 2 electrons. It's a +2 charge. Oops. Like the way it looks. There we go. And my nitrogen, my second nitrogen, has its 5 electrons. 1, 2, 3, 4, 5, 6, 7, 8. And it had 5 electrons and gained 3, so that gives it a -3 charge. And then when I go to write my chemical formula, I count up what I have. So I have 3 strontiums and 2 nitrogens, so it becomes Sr3N2. Some points that you should kind of keep track of is metals are naked. Nonmetals are fully clothed. So no valence electrons, 8 valence electrons. Metal should have a positive charge. Non-metal should have a negative charge. Any questions about this? Okay. Moving along. Here we have our compounds that are chemical formulas, and we're going to write the names. So first thing I usually do is I check the back of my periodic table, and I don't see MgCl on the back of my periodic table, so I know that I'm dealing with a metal and a non-metal. So I go and I locate the metal on the periodic table, Mg, and that's magnesium. And I locate the non-metal on the periodic table, which is chlorine, but I drop the INE and change it to chloride. And the name there is magnesium chloride. In my next one, I check the back of my periodic table, and I see that I have acetate, which is C2H3O2 minus 1. So I do have a poly, and I'm going to simply write its name so I don't forget it. And then I see on the front side, or I also have a metal, which is in group 1, and so that K is potassium. Acetate would be my final answer here. Check the back of my periodic table, and I don't see T, I, or O anywhere. So I know that I'm dealing with a nonmetal. Oops, wrong one. And a metal. But specifically, Ti is located right here in the D block, which means that it's a transition metal. So we're going to have to do a little bit of voodoo math to get to the point where we know what the transition metals Roman numeral is going to be, or the transition metal charges. So I'm going to start with oxygen. Oxygen is in the 16th column of the periodic table, which means it's got a charge of minus 2. So I know that oxygen is a minus 2 times its subscript, which is a 3. So that becomes a minus 6. I change the minus 6 to a plus 6, and then I divide by the subscript of titanium, which is 2, and I get plus 3. So that tells me that the charge of titanium is plus 3. So I'm going to write titanium, Roman numeral 3, oxide. We'll do the last one in this part. So ZnS, not back here. So I'm assuming it's going to be a metal and a non-metal. So specifically, I do have a non-metal, but I also have a metal. Zinc is a transition metal. It's column 12. So it's my transition metal. And I know what you're thinking. You're saying to yourself, oh, I got to do all that math again, and I got to write a Roman numeral. And I would say, hold on. At one point or another, we talked about the idea that there were 3 elements that were transition metals that were always the same charge. So in this case, zinc is always a plus 2, cadmium is always a plus 2, and silver is always a plus 1. So if that's the case, I don't have to write a Roman numeral, and I also don't have to do the voodoo math to get there. So that means I'm going to have zinc and sulfide. Any questions here? Yeah, so because zinc is always a +2, there's no need for a Roman numeral. All right, next section. We're going to now write the chemical formulas based on the names that were given. We have rubidium nitride. There is no rubidium nitride on the back of my periodic table, so that tells me that it's probably going to be a metal and it's probably going to be a nonmetal. I located rubidium on my periodic table. It was in the first column, and everything in the first column has one valence electron, so its charge is going to be a +1. So that tells me that rubidium is +1. Nitride is in column 15 on the periodic table, has 5 valence electrons, so it's going to have a +3, or I'm sorry, 3 minus, because it's going to gain 3 electrons. We crisscross the charges down. We get rubidium, Rb 3 and 1. I check my ratio, which is 3 to 1. I can't really simplify that anymore, but I don't write ones, so my final answer is going to be Rb 3N. Next one is cobalt chloride. Looking on the back of my periodic table, I don't see a cobalt or a chloride, so that tells me that it's going to be a metal and a nonmetal. So I've got my nonmetal for sure, but I see a Roman numeral, so that tells me it's a transition metal. And that's true because cobalt is right here in the middle of the D block, cobalt CO. So this Roman numeral tells me the charge of cobalt. So in this case, I have cobalt is a +3 and chloride is a -1. We crisscross the charges down. We get cobalt 1, chloride Cl3. So CO1, Cl3. I'm going to check my ratio. And I see it's 1 to 3, and I can't simplify that anymore. So I don't write ones, so this is going to end up being cobalt Cl or CoCl3, like that. Now, the next one is calcium hydroxide. And I'm going to once again consult the back of my periodic table, and I'm going to see that, yep, hydroxide is on the back of my periodic table. And as a result of it being on the back of my periodic table, it's a polyatomic ion, and it's OH -1. So hydroxide is polyatomic, and we know that it's OH -1. I usually put those in parentheses at this point. And then calcium is a metal. And on the periodic table, it is a charge of +2. Crisscross the charges down, and I get CaO1OH2 in parentheses. And now I'm going to check my ratio real quick, which is 1 to 2. I can't really simplify that anymore, but I don't write ones, so I'm going to get CaOH2. And the OH, the hydroxide, has to be inside parentheses, and the 2 has to be outside the parentheses. All right, we got one more. I realize we're running up against the end of the hour. If you stick around, great. If not, I'll be posting this, so quiz tomorrow. Cadmium fluoride. Okay, I don't see cadmium or fluoride on the back of my periodic table, so that tells me I'm dealing with a metal and a nonmetal. Specifically, cadmium is a transition metal. But it doesn't have a Roman numeral, so that means that, it must be one of the ones that is always a +2, +1 something. So cadmium, Cd, is a +2. So I don't even need the Roman numeral for that one. So I'm just going to write cadmium +2, and then I have fluoride, F, which is a -1. Now, in this instance, we're going to crisscross the charges down. We're going to get CD1F2. I'm going to check my ratio, which is 1 to 2. Can't simplify that any further, but I also don't write ones, so it's going to become CDF2 is my final answer. If you have any questions about this answer key or any of the problems that we went through over the last few days in class, I highly suggest you reach out to your teacher and be prepared for your quiz tomorrow. Have a good afternoon and goodbye.